Okay guys, so now we're going to be doing second order differential equations. And so a second order differential equation really deals with the higher derivatives. So it normally follows the form a times d squared y by dx squared plus b times dy by dx plus c. And there are two types of second order differential equations that we'll look at in this video. So the first one we'll look at is homogeneous. So it's homogeneous when this is equal to 0. And when it's not equal to 0, it's non-homogeneous, but we'll look at that later. So right now we're going to focus on homogeneous second order differential equations, which just means they're equal to 0 and they have a higher derivative, like, well, not higher, but d squared y by dx squared, so the second derivative. Cool, but how do we solve these? So we solve these by making what we call an auxiliary quadratic equation. And what it really is just, this is to the power, this is going to be squared, right? And then this is just dy by dx, non-squared. So we could use variables and create a quadratic equation, and so the quadratic equation would just be creating a variable for this. So for example, we would have a m squared plus bm plus c equals 0. And this is where m is equal to this. If m is equal to dy by dx, then it will be am squared plus bm plus c. And when we get this, what we actually have now is a quadratic equation, and this will allow us to solve second order differential equations when they're homogeneous. Cool. So let's try a problem. So if I ask you to solve the differential equation, which is d squared y by dx squared plus 2 dy by dx plus y equals 0, how would you go about doing that? So this is actually so much easier than first order differential equations in my opinion, but let's go ahead. So remember, we're just going to make it into a quadratic equation. So we're going to pick a variable, and typically, I'm not sure why, but we typically use m, or at least that's what I saw when I was learning it. So we're going to let this be m squared, because if we let m equal dy by dx, then this is m squared, and this is just going to be plus, we're going to keep the coefficient, which is 2, so plus 2m. And no, what is the coefficient of y? Do we just put plus y? Because that's not how that's going to work. We're going to use the coefficient of y. So the coefficient of y is 1. And so it's going to be equal to 0. So once it doesn't have a dy by dx in there, we are going to use the coefficient of that number. So for example, in y in this case, the coefficient of y is 1. And now we actually just have the answer. All we have to do now is find find the roots. Because this whole topic really just depends on the roots. So you'll find a general equation. So they'll ask you to find the general equation of the second order differential equation. Or they might not say that, they might just say solve it. But you'll have to find the roots, and using the roots you can find the general solution. And I'll show you how. So first, let's solve this. So if you don't know how to solve a quadratic, you should probably look that over, because it's going to be very important for this topic and like all topics in Unit 2. But let's go. So two numbers that multiply to 1, add to 2, so that's m squared plus m plus 1 equals 0. m plus 1 plus 1 m plus 1 equals 0. We'll have m plus 1 times m plus 1 equals 0. So does this mean? It means that we have m plus 1 squared equals 0 as a root. Now what does this mean? It means that, well, m is equal to -1. That means that the root is -1, and since it's a repeated root because it's being squared, we have the same root twice. So we have m equals 1, and we have m equals -1, and we have m equals -1 again. So since these roots are real numbers and they're repeated, this is how we would find our general solution. So when the roots are real and they're the exact same, by real I mean they're not imaginary, okay, and they're not trigonometry. They're not trigonometry and they're not imaginary. They're just normal numbers like this. We say that the differential equation, or the general solution rather, is given by y is equal to ax plus b times e to the mx. Now in this case, m is just going to be equal to your value, or the value of m that you just got here. So we basically have our answer. We just have to substitute that in. Y is equal to ax plus b times e to the negative x. And that's essentially all you have to know for this topic. So let's try one more question, and then we'll go into some past paper questions, because this is actually, no, sorry, we're going to go into the other types first before we do past paper questions. Yeah, this is just one. So this is, I've only shown you when the roots are real and the same. So let's try one more example of that, and we'll try a different type, like when the roots aren't real and the same, okay? So let's go now. So let's say I ask you to solve d squared y by dx squared plus 10 times dy by dx plus 25y is equal to 0. Well, how would you solve this? Well, again, just make your auxiliary quadratic equation. So the AQE is going to be equal to m squared plus 10m plus, and remember we use the coefficient of y, plus 25, which is equal to 0. I'm not going to factor this because it's kind of like it's a perfect square factoring, so I'm just going to write factor, which is m plus 5 squared, and that's going to, that's going to equal to 0. But that means that our m value, or root, is equal to -5, and it's repeated, so it's real and repeated. So that means, following the form that we just showed above, y is going to be equal to ax plus b times e to the -5x, because remember this is e to the negative, well sorry, this is e to the mx, and in this case our m is -5. Cool. So what do you do now when the roots are not equal? So let's try a different example and see how we do with that one. So what if I ask you to solve 3d squared y by dx squared plus dy by dx minus 2y equals 0. Again, you're going to just make your auxiliary quadratic equation. So you're going to have 3m squared plus m minus 2 equals 0. And in this case, now we're going to have to find two numbers that multiply to -6 but add to +1. So that's -3. Well, sorry, -2 +3. So it's 3m squared plus 3m minus 2m minus 2 equals 0. Again, just factoring it. So now you'll notice that our roots are 3m minus 2 and m plus 1. So what are our individual roots then? Well, we can say that our roots are it's either 3m minus 2, that means that m is going to be equal to 2 over 3 when we equate it to 0, or m is equal to -1. And so what you can do is you can say, well, this is going to be my m1 value, and this is going to be my m2 value. And you just have to kind of put like m1 or m2, because that's what you're going to need to do to find the general solution. And so when the roots are not the same, when the roots are different and they're still real, that means that they're, they're not trigonometry, they're not imaginary, then this is how we're going to find the general solution. The general solution is given by y is equal to a times e to the m1x plus b e to the m2x. Again, very simple. Legitimately, you only have to know how to solve quadratic equations, but you also have to know how this general formula, I guess. So there's that. So once you know how to do that, then you just have to substitute it. Or m1 value is 2 over 3, so y is equal to a times a to the power of 2 over 3 x plus b times e to the power of -x. And that's all we have to do for that. So now let's look at what we can do if it is that the roots are complex. So if you notice, so far I've only been using examples which have real roots. So let's try something that isn't real. Okay, so what if I ask you to solve d squared y by dx squared plus dy by dx plus y is equal to 0. Again, we're just going to instantly create our AQE, which is going to be m squared plus m plus 1 equals 0. Now if you realize, we can't use the AC method for this. 1 times 1 is 1, because 1 times 1 is 1, but 1 plus 1 is 2, so we have to use the quadratic formula. So we're going to say that m is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so that means that m is going to be equal to negative b, so our b value here is 1, so negative 1 plus or minus the square root of b squared, which is 1 squared, minus 4 times 1 times 1, so minus 4 all over 2 times 1, so it's just 2. So simplifying this, we'll have m is equal to negative 1 plus or minus root negative 3 over 2. Okay, so now this deals with complex numbers. Why? Because we're going to have something under a square root that is negative. So when we have something like that, so let's say we have root negative 3, this is the same thing as saying root 3 times root negative 1, but we know that root negative 1 is equal to I, so it's going to be the same thing as saying root 3 times I. So we can use this instead of using this, because negative in a square root is just, I don't know, it's just not done, I don't think, at least. I don't know, maybe at the higher levels of math, I have no idea. I only know K-math. But let's go. So we have m is equal to negative 1 plus or minus root 3 I over 2. Now if you realize, this is a complex number, but we have a real component and we have an imaginary component. And if you watch the complex numbers video, you'd probably understand that that is how a complex number is made. So now let's go ahead and continue trying to solve it. So what does this mean? It means that we have roots, right? So for complex numbers, what you should do is just pick one of the roots. So if you notice, it could be negative 1 plus root 3i over 2, or it could be negative 1 minus root 3i over 2. So for the sake of, well, to solve them, you actually just have to pick one of them. So I'm going to pick positive, so I'll say m is equal to negative 1 plus root 3 over 2, plus root 3i, that is. And just to make it more, just to make it simpler, I like to just reduce the fraction. So the fraction is going to actually just be negative 1 over 2 plus root 3 over 2 times I. And so this is our value, and this is all we had to do to actually solve this. As I said, it's really just quadratic equations and factoring. But now you have to know the general equation, or the general form. And the general form is a little bit different. It's a little bit more, but it's not that deep. So if it is that you have roots and they're real, well, sorry, not real, sorry, they're complex, this is what you're going to do. You're going to say y is equal to e to the m1x is going to be multiplied by a cos m2x plus b sine of m2x. And what's m1 and m2, you might ask? Well, m1 is simply your real part, and m2 is your complex part. So knowing that, we can say y is equal to e to our m1, m1 is negative 1 over 2x, times a cos of root 3 over 2, root 3 over 2x, sorry, yeah, plus b sine root 3 over 2x. And that's simply how we do homogeneous differential equations. That's the entirety of it. If you'd like some extra practice, I'd recommend that you go and try some questions from a textbook, or maybe ask your teacher. But I don't really have any extra practice questions right now, but we'll be doing past papers anyways, so you'll get some practice for that. But now we're going to move into non-homogeneous. So non-homogeneous. Non-homogeneous second order differential equations. So non-homogeneous differential equations is when it's not equal to 0. So we had the same form, which is a times d squared y by dx squared plus b times dy by dx plus c times y should be equal to 0. So this is what we knew that. This is what we knew for homogeneous. So for non-homogeneous, it's just when it's not equal to 0. Okay? And so we're going to be looking at what happens when this right-hand side over here is a polynomial, when it's an exponential function, or when it's a trigonometric function. But the foundation was set from the homogeneous differential equations, because that's just half of what you had to do actually. So you'll see what I mean first when we try our very first example. So let's try when the polynomial, well, the right hand side is a polynomial, okay? So we're going to say we are going to have d squared y by dx squared minus 6 dy by dx plus 9y is equal to 4x plus 1. So how will you go about solving this? Now, I'm going to take a sip of water. 1 second. Okay, well, these are solved in the exact same way, they just have another step. So the general solution for these is given by the complementary function plus the particular integral. Now you might not know, well, if you're watching this video, you probably don't know what either of these are, but that's fine. We will go through that right now. So the complementary function deals with the left-hand side. And if you notice, we legitimately just dealt with the left-hand side with our AQEs. So it's the exact same thing as you do with a homogeneous differential equation. You just do the exact same thing, and that's a complementary function. So for example, in this case, let's make our AQE first. So we're going to have m squared minus 6m plus 9. And we're just going to equate it to 0 because that's what AQEs are equated to. And then we just have to solve for m. But in this case, if you look at that, we'll see that m minus 3 squared is equal to this. If you don't know these things yet, you should probably look at perfect squares. But after a while of just doing a lot of these, you just kind of fit them up. But yes, this is m minus 3 squared. And that means that our root is m equals 3. And what do you notice about this root? Since it's squared, it's the same root twice. So that means it is repeated. And if you notice, 3 is in fact a real number. So our complementary function is legitimately going to be the same thing as our general equation for a homogeneous differential equation. It's just going to be equal to what? So do you remember the form that we use when the roots are real and repeated? Well, it's going to be ax plus b times e to the mx. So remember, there's only one m because there's one value for the root, and it's going to be e to the 3x. So this is half of our work done, and it's legit just from what we knew from homogeneous. But now for the particular integral, we're going to deal with the right-hand side of the equation. So the particular integral is a little bit different. So the particular integral deals with the right-hand side. So we're going to just say, I'm just going to put 4x plus 1 here because this is what we're going to be doing something with. And so what do we do? So we say, since this polynomial right here is of degree what? Well, the highest power of x is 1. So we say since this is of degree 1, then we're going to let y, just any y, we're going to let it follow that form. So we're going to say y is going to be equal to, and I like to use ax plus b. We're saying that it should follow this form. And then we're going to say, okay, well, that's cool. What if we find dy by dx? So dy by dx should be equal to, well, if you find the differential of this is going to be equal to a. And then if we find the second differential, like the second derivative, sorry, it's going to be equal to 0. And you might be wondering, okay, like this is, I didn't explain what the particular integral was because you kind of don't really need to know it. You just have to know how to use it. So we look at this over here. We just try to mirror the exact form. So we say ax plus b. We find the first derivative and the second derivative. Why do we do this? We do this because we want to use these values right here. And what we're going to do with them is we're going to plug them into our equation right here. So where we have dx squared, we'll put our 0. Where we have dy by dx, we'll put whatever we got for that. And where we have y, we'll put what we got for that. Okay? So let's try that. So let me just rewrite the equation real quick. So the equation was m squared minus 6m. Oh, sorry. This is supposed to be not AQE, like the actual equation. It was d squared y by dx squared minus 6 dy by dx plus 9y is equal to 4x plus 1. So in substituting this, we know that dy by dx, well, sorry, d squared y by dx is equal to 0. So substituting that, we can put 0 minus 6 times, well, dy by dx itself, the first derivative is just equal to a. So where we have dy by dx, we'll put a instead. So minus 6 times a, and then plus 9 times y. Well, what did we let y equal to? We let y equal to the form of the right-hand side, which is ax plus b. So plus 9 times ax plus b should be equal to 4x plus 1. And all we have to do now is equate the coefficients eventually, so we just have to kind of solve. So we're going to have minus 6a plus 9a, oh, plus 9ax plus 9b should be equal to 4x plus 1. Okay, so what do you notice? Well, you notice that there is one x term and a term that deals with a and b. So I just had to put them all in the same order. So we're going to say we have 9ax minus 6a plus 9b should be equal to 4x plus 1. If we equate the terms that have an x, we equate the coefficients of x by equating polynomials, we would know that 9a is equal to 4. That means a is simply equal to 4 over 9. Now we also know that minus 6a plus 9b should be equal to what? What should this be equal to? These values are constants. It should be equal to the constant value, which is 1. Now we know that a is equal to 4 over 9, so we're going to have minus 6 times 4 over 9 plus 9b should be equal to 1. Now 3 into this goes 2 times, 3 into this goes 3 times, so it's going to be 8 over 3 minus 8 over 3 plus 9b is equal to 1. So that means 9b is equal to 8 over 3 plus 3 over 3, 11 over 3. That means that b, when you divide both sides by 9, is equal to 11 over 27. So what do we do with this now? Well, what you simply do is you just put that into what we let y equal to. At first, we let y equal ax plus b, right? So we said at the very start of the particular integral section, y is equal to ax plus b. We just substitute our values for a and b here, so we know that b is 11 over 27, and we know that a is 4 over 9, so a is 4 over 9. So we say that y is equal to 4 over 9x plus 11 over 27, and this is our particular integral. So this is legit just your pi. And remember that the general solution is equal to the complementary function plus the particular integral. So you just have to add the two. That's actually a lot of writing, so I'll leave you guys to that. But yeah, that's what you do if it is that it is a polynomial to the degree 1. Whatever this right hand side is, you just want to follow the form. So I'm not going to show like an example of every single option. I'll just give you an example of the particular integral because it's the exact same thing that we did. Most of it is the exact same thing that we did for the homogeneous, so I'll just show you how to get a particular integral. So for example, if we had a times d squared y by dx squared plus b times dy by dx plus cy is equal to a cos mx plus b sine mx. What we're going to do is we are going to say that our particular integral follows that form, right? So the pi is of the same form. So if this m could be anything, it could be a cos 2x, you'd put cos 2x in the next thing, and if it was b sine 2x, you'd just follow the exact form. Whatever is inside the parameter for cos or sine, you're going to just do the exact same thing for your particular integral when you're saying its general form. So if I, for example, had d squared y by dx squared plus dy by dx minus 6y is equal to cos x, what would you say the form of the particular integral is? Well, the form of the particular integral is y is equal to a cos x plus b sine x. Well, in this case, the m value is 1, so we're just going to say a cos x plus b sine x, and we're going to find our dy by dx and or d squared y by dx. And that's how you'd find the particular integral for anything dealing with trigonometry. Now again, we're going to just go really quickly over the exponential form because the exponential form is the exact same thing. So if we had something like d squared y by dx squared minus dy by dx minus 6y is equal to 4e to the 2x. Well, what would you say the general solution is? Well, you'd find the AQE, do the the normal stuff for the first part for the complementary function. But to find the particular integral, we say it's dealing with the right hand side. So we need to get something that mirrors the right hand side. So in this case, we want it to mirror what? Well, if you look at the right hand side, what form does it mirror? You should think about this right now. So the form is going to mirror a, which is a constant value, times e to the mx. Now in this case, we look at m, where m value is actually 2. So it's going to be equal to a e to the 2x. But what is our a value? We realize our a value is 4. So it's equal to 4e to the 2x. And so this is just turned into this, because this is the general form that this follows. So hopefully you're following yourself. But yeah, that is essentially how you do second order differential equations. And now we'll be going into some past paper questions. Why did I click 2021 first? I think when I was getting this question, I was like, nah. Oh, actually, no, it's not that bad. Okay, let me just have a sip of water and we can start this one. Alright, so the question asks to determine the general solution of the differential equation. Okay? And it gives us they give us a differential equation. I just decided to write them out real quick. So y prime prime plus 2y prime plus 5y is equal to 0. So the first thing you should notice is that it's the right hand side is equal to 0. This means that it is a homogeneous differential equation. What does that mean? It means that we solve using our AQE. So we'll be left with m squared plus 2m plus 5 is equal to 0. So we need a number that multiplies to 5 but adds to 2. There is no such number, so we have to use the what do you call it? The quadratic formula. So m is equal to minus b plus or minus the square root of b squared minus 4ac all over, oh, some lean line, some really lean lines, all over 2a. So we see that m is equal to, or b value here is 2, so minus 2 plus or minus the square root of 4 minus 20. A is 1, b and c is 5. All over 2 times 1, which is 2. Moving from that, we're going to say that m is equal to minus 2 plus or minus the square root of negative 16 over 2. Now, as is equal to, we'll remember that root negative 16 is just equal to root 16 root negative 1. Root negative 1 is just equal to I. Root 16 is just equal to 4. So we'll be left with 4i. So that means that we're going to have negative 2 plus or minus 4i over 2. So that means that m, when you simplify, is simply equal to negative 1 plus or minus 2i. Now, the first thing you should notice is that this is a complex number, so we have to remember the form that we use for complex numbers. The general form is y is equal to e to the m1x, where m1 is the real value, times a cos m2x, where m2 is the imaginary part, plus b sine m2x. And I don't put the brackets, but these are the parameters of cos and sine. I just can't bother to put the brackets myself, but you should put brackets. But yeah, this is the general form, and since it's homogeneous, this is all we have to do. So we just have to plug in our values. So we know our m1 is negative 1. So we say y is equal to e to the negative x times a cos 2x plus b sine 2x. And that is how you would get that answer. Pretty simple. Hopefully you understood that one. Let's move on to another question. So this one is going to be 2022. So this one is just 2 years ago. It's pretty recent, but let's see. So it asks us to determine the general solution of the differential equation, and it gives us a differential equation. So I'll just write it really quickly. So we have y prime prime minus 7 y prime plus 12y equals sine x minus cos x. So immediately I notice that the right hand side is not equal to 0, so we're dealing with a non-homogeneous second order differential equation because this is y prime prime, so it's y, so it's the second derivative. So I know I'm going to have to find a complementary function and that particular integral. So knowing that, what I'm going to do is I'm going to just quickly make our AQE. So AQE is going to be, what's it going to be? It's going to be m squared minus 7m plus 12 is equal to 0. So we need two numbers that multiply to 12 but add to negative 7, so that's negative 3 and negative 4. So m squared minus 3m minus 4m plus 12 equals 0. m minus 3 minus 4 m minus 3 equals 0. So we'll have m minus 4 and m minus 3. Okay, so what do we do with that? Well, now we're just going to set this equal to 0, so that means that coming up here, that means that m is equal to 4 or m is equal to 3. And when we have two values like this, I decided to let this one be m1 and this one be m2. So that means that our general solution, well, our complementary function, is going to be given with the form y is equal to a times e to the m1x plus b e to the m2x, because they're real and distinct. The solutions are real and distinct, so they're different, so we're going to use this formula right here. So that means that y is equal to a e times, oh, I said a, but I wrote e, a times e to the 4x, sorry, it's supposed to be m2, plus b times e to the 3x. And, well, that is our complementary function. So we're just going to save this for later. I'm actually going to copy it so that when it's time to rewrite it, we don't have to do any rewriting. But yeah, great. Now that we have the complementary function, we have to work on the particular integral. So the particular integral deals with the right hand side. So let's come down here. So we're dealing with sine x minus cos x. Well, what form does this follow? Well, in this case, we would say that the coefficient of cos x is -1. So you still follow the form y is equal to a sine x plus b cos x. Oh, sorry. Is it a sine x plus b cos x? Like, it depends. I think I get mixed up sometimes, but sometimes it depends on who taught you. But sometimes people do a sine x plus b sine x. But let me just check real quick which one. Wait, which one did I use up here? I use a cos x plus b sine x. So I'll use that one again because sometimes I get confused. I don't think it really matters, but just to keep everything the same. A cos x plus b sine x. Now what we do, we take the derivative, so dy by dx is equal to, remember this is a lot of product rule, so yeah, just be lucky that it's not like no parameters, because when there are parameters in the cos and sine, it can get really tedious. So the differential of this is a times, so the differential of cos x is negative sine x, so negative a sine x plus b cos x, and then d squared y by dx squared is equal to the derivative of sine x is cos x, so negative a cos x minus b sine x, because the derivative of cos x is sine x, is negative sine x. So now we just have to take this and we'll plug it into our equation, which is y prime, I'm going to write this back, y prime prime minus 7y prime minus 12y equals, what's that, sine x minus cos x. That's why I got mixed up, because it said sine x minus cos x. I really don't think it matters, but either way, we'll just write it all like that. So our d squared y by dx squared, our value for that is going to be negative a cos x minus b sine x. And then we're going to have minus 7 times the first derivative, which is going to be negative a sine x plus b cos x, and then minus 12 times y, which is equal to a cos x plus b sine x. And that should all be equal to sine x minus cos x. Okay. So now we really just have to expand the brackets, but yes, this gets really tedious, especially when it's weird like this. But anyways, let's go. So we're going to have negative a cos x, and then we're going to have minus b sine x. Then when we go through here, we're going to have plus 7a sine x minus 7b cos x minus 12a cos x minus 12b sine x is equal to sine x minus cos x. Wow, that's a lot of things to write in one line. Okay, so now what do you need to do? Well, you need to organize everything together. Let me just check it. Okay, so we're going to add all like terms together, and by like terms I mean the sines, not the cos's. So we're going to organize the cos together and the sine together. So let's do the cos first, since cos starts here. So we're going to have negative a cos x. So we did this one. Let's go for another cos. Okay, so minus 7b cos x minus 12a cos x. And if we're equating the cos x's, that means this should be equal to nothing but negative cos x. Now if you notice, everything here is negative, so we can actually just kind of remove the negative sign. Because if we multiply both sides by -1, it cancels out. So we'll just be left with positive everything here. And we love positivity, so that's good. And now we have to deal with signs. So we're going to have a negative b sine x. So we did this one plus 7a sine x minus 12a sine x. And that should be equal to the coefficient of sine x here, which is just 1 sine x. Now what we have to do is we have to equate the coefficients. So what we do is we say that, oh well, there should be plus in between these, and I guess these two can simplify, but we can do that now. So we have to equate everything to the coefficient. So by that I mean we're going to take out the costs, because we can divide by costs. If you divide it by costs, you'd be left with just 1 on everything here, and we just deal with the coefficients. So now we'll have a plus 7b plus 12a is equal to 1. So that means that we know that 13a plus 7b is equal to 1. Just rewrite that instead. So 13a plus 7b is equal to 1. And then for our next equation, we're going to just divide by sign. And we'll say we have, well, okay, so we're going to have negative b plus 7a minus 12a should be equal to 1. So plus 7a minus 12a is going to be equal to negative 5a. And I like to put these in the different order, so negative 5a minus b should be equal to 1. So if you notice now, we just have two simultaneous equations, and we can solve for a and b really quickly by just finding them. But before that, if you realize, we could just, well, it's fine. So let's multiply equation 2 by 7. So if you multiply, this is equation 2 by the way, by 7, we'll have 13a plus 7b equals 1. But then for equation 2, we will have a negative 35a minus 7b should be equal to 7. Wait, what did I multiply by? Yeah, I multiply by 7, yeah. Okay, and all we have to do now is just add the 2. We add the 2 so that these two cancel out. 7 plus 1 is 8. 13 plus negative 35 is, that's going to be, oh yeah, why am I so lost on this math right now? 22. Yeah, so negative 22a is equal to 8. So that means a is equal to negative 8 over 22. which is just equal to 4 over 11. So that's our value for A. Now we can find our value for B, because we know that minus 5A minus B is equal to 1. So that means minus 5 times 4 over 11 minus B should be equal to 1. So this is the same thing as saying negative 20 over 11. So that means negative B is equal to 1 plus 20 over 11, which is just simply 31 over 11. And that means that B is equal to negative 31 over 11. And all you have to do is just put these back into the general form, which is A cos x plus B sine x. So if y is equal to A cos x plus B sine x, so A is equal to 4 over 11, A A is 4 over 11, so y is equal to 4 over 11 cos x plus b, which is negative 31, so minus 31 over 11 sine x. And we're just going to have to add this to the complementary function. This is a lot of adding, I can't lie. Oh, I saved it, I just remembered I saved it, so I should be good. But yeah, so this is what we'd have for for particular integral. So to get the general form now, we just have to add these. Oh no, this is not good. I didn't solve the rest of the correct thing. That's unfortunate. Well, it happens. So instead, I'm going to just trust that you guys can add this because it's the particular integral. So you add this to the complementary function that we got above. Where is it? Here. Just add it to that. Wait, am I lost or did I? Oh yeah, I'm just lost. I don't know what I did. So, but yeah, so you just add it to that and you should get an answer. Yeah, but that question was pretty weighty. It was pretty rough. How many marks is this? I didn't screenshot the marks, my bad. But let us do the very last question for today. So this one says solve the boundary value problem of y prime prime minus y prime minus 2y equals 0. And they give us some values of x and y. So let's quickly start doing that now. So they told us that y prime prime minus y prime minus 2y equals 0. Well, that simply means that we can find our auxiliary quadratic equation, because this over here on the right side is 0, so it is a homogeneous differential equation. So we'll find our AQE by doing m squared minus m minus 2 equals 0. Two numbers that multiply to negative 2 but add to negative 1, so multiply to negative 2, so 1 and negative 2, and add to plus 4. Oh, that's exactly it. So we're going to have m squared plus m minus 2m minus 2 equals 0, which is m plus 1 minus 2, m plus 1 equals 0, m minus 2, m plus 1 equals 0. So that means that we have m is equal to 2 or m is equal to negative 1. So m1 is equal to 2, and we can say our m2 is equal to negative 1. So since the roots are real and distinct, we can say that the general equation is going to follow the form y is equal to a times e to the m1x plus b times e to the m2x, which means that y is equal to a e to the 2x plus b e to the negative x.